Before discussing the definition of the pressure, let us have some examples from the daily life. You might have seen camels, and you might have also heard the verse of Quran. If you have read Surah Ghashiyah, which is the Surah 88 of Quran. Yes, very good. MashaAllah, MashaAllah, Subhanallah. أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم أفلا ينظرون إلى الإبل كيف خلقت وإلى السماء كيف رفعت وإلى الجبال كيف نصبت. Now, أفلا ينظرون إلى الإبل كيف خلقت. Can anybody tell me the translation of this? The translation of this, then do they not look at the camels how they are created? Do they not look at the camels how they are created? أَفَلَا يَنْظُرُونَ إِلَى الْإِبْلِ كَيْفَ خُلِقَتْ. Do they not look at the camels how they are created? Then Allah Pak says in ayah number 19, وَإِلَى الْجِبَالِ كَيْفَ نُصِبَتْ وَإِلَى الْجِبَالِ كَيْفَ نُصِبَتْ. And at the mountains how they are installed. And the mountains how they are installed. From these two ayah, Allah is inviting you to think about it, that what are the natural laws He is going to give you to make your life easier. Like He is inviting you to see at the creation of camel, that how camel can travel. There are many things in a camel which you can find it out in your daily life, that how the camel can walk on sand. Now here we are going to discuss only one factor about which our topic pressure is related. That is that how the camel is walking on sand or the soft land. How the camel is walking on the soft land. Why it is easier for camel to walk on sandy deserts. Yes, the large flat fields of the camel are helping the camel to walk on the soft sand or soft land very easily, because the whole of his weight is spread over on a large areas of his 4 feet. We have discussed different effects of force. Like I told you that force can produce acceleration in the body. We also discussed that force can change the shape of the body. This was also discussed. We also discussed that the force can do work. Okay? So deforming forces, we also discussed different effects of the forces. Now here in this case we are going to discuss that how the pressure and area are related with each other. So simply we say that pressure is the force per unit area. So this is the definition of the pressure, that the pressure is the force per unit area. That on a unit area, how much force is going to be exerted. How much force we are exerting on a unit area. So if we are going to find out the result, so that resulting quantity, that is force over area, is called the pressure. As for the formula is concerned, so pressure is equal to force over area. Force per unit area. So this is the formula for pressure. And you know that we use Newton for force and area meter square. So Newton per meter square. 1 Newton per meter square is equal to 1 Pascal. Okay? So remember this, we can use these two units for pressure, Pascal or Newton per meter square. And you must remember that 1 Newton per meter square, not centimeter. Here, whenever you are using Newton per meter square, we can say Pascal. Okay? So if it is centimeter square, we can also say Newton per centimeter square. But if you are going to use centimeter square, then Newton per centimeter square is not equal to Pascal. For converting into Pascal, you must remember that Newton per meter square. Is that clear? The force and area are interrelated with each other. How they are interrelated with each other? So that relationship of force and area basically we are going to discuss here, that is pressure. So if we are going to define pressure, that is pressure is the force per unit area. This is the formula for pressure. So here you can see that the pressure is depending upon two things. Pressure is depending upon two basic things. One is the force and other is area. From this formula, it is very clear that pressure is depending upon how many things? Two factors. Pressure is depending upon two factors. One is the force and second is the area. So we have to see that whether this pressure is directly or inversely proportional. So actually pressure is directly proportional to the force applied. It means the greater the force, greater will be the pressure. Pressure is directly proportional to the force applied. It means if you have more force applying on a certain area, on a unit area, then pressure will be more. So pressure is directly proportional to force. And pressure is inversely proportional to area. More the area, lesser will be the pressure. More the area, lesser will be the pressure. So pressure is inversely proportional to area and directly proportional to the force applied. You know that this handle with which you are carrying this, it has broader area. So whenever you are carrying it, you don't feel pain in your hand while like this. Let's suppose I have this styrofoam piece. So if I am keeping it like this, so you can see that it is easier for me to pick and it is not being damaged. This styrofoam piece is not damaged because this is the wider area, okay, to carry it. Now, if instead of this, I am using this thread. So while tying is with the thread, what I am doing basically, I am decreasing the area. Here the area was larger, but here I have decreased the area. Now what will happen? What do you think? The weight is the same. The weight of the bag is the same, whatever it was initially. Okay? So, but when I am lifting it with this, so area is decreased. So what will happen? Let us see. So if I am okay, now so it has okay, so you can see that when I was lifting it with this, so it was not deformed. So when I was lifting it with this, so you can see that the pressure was lesser on this, although the weight is the same, but the pressure on this styrofoam was lesser. But because the area was larger, but when I was lifting it with this, so pressure has increased with the same weight or with the same force. The pressure has decreased because this area is smaller area. Well, actually the pressure in solid is depending upon area. As I told you that if you are increasing the area, the pressure decreases. If you are decreasing the area, the pressure increases. See that this is the ladies' sandal heel. Its area under this pencil heel is, say, it is 1 centimeter square, and the area under this boot, say, it may be 30 centimeters square. Okay, so area under this heel is about 30 centimeter. Now, let us suppose a normal man which is having 50 kg mass, may be having the weight of 500 Newton. 500 Newton weight. This is also having the 500 Newton weight. This heel will injure your feet more, or this heel? This lady's heel will injure more. In case of studs, you can see that why the studs are something like spikes under it. Spikes like this are found in the studs for a good grip, because if you are going to wear your common boot like I am wearing here, if I am going to kick a football like this, then with the pressure, with the momentum of this leg will also go further again, and I will fall backward. So these studs are basically, these studs penetrate into the land and they give a good friction, so that if he is kicking the football or he is moving here and there, he must not be slipping like this. Okay? Yes. Let us consider a block like this, a rectangular block. आप लोग बजाय इसके कि एक मजीद उसमें पढ़ो 4 meter, 3 meter, 2 meter. These are the dimensions of this rectangular block of any material. Suppose its weight W is equal to 24 Newton. Now you have to see that in which orientation its pressure will be greatest. Orientation, for example, if this is the rectangular wooden plank, whatever. So if I am placing it like this on a surface, so will the pressure largest? Least pressure, because more area is under it. Yes. If I am keeping it like this, then it is more lesser. If I am placing it this, then in this way, the pressure under this will be the largest. Remember this, that we have to see that how much pressure is on the surface at which it is lying. If I am placing it in this orientation, then under this you will have to see the area under this surface. If this area under this surface is the least, it means the pressure is the largest. So if I am placing it like this, so when I am placing it like this, then area under this surface is the largest, so pressure will be the least pressure. Now we are going to see this with the help of the calculations, that how the pressure is affecting due to this area. So if I am placing it this like this, and 24 Newton is the weight of this object. So to calculate the pressure in this orientation is equal to force over area. Which area will come here? 4 multiplied by 3 is 12 meters square. So here the area under this is 12 meters square. So pressure in this case is equal to force over area. So this area under this block 12. So here the pressure is 2 Newton per meter square or Pascal. We can say also Pascal. Now if I am placing this block vertical, like if this block is lying like this, this is 4, this is 3, this is 2 meters. Now the same block which was previously lying like this. So if this block is lying this, its weight is 24 Newton. Now when this block is lying this, so area under this 4 into 3. You have to take this area 4 into 3. So 24 divided by 12 gives you 2 Newton per meter square or 2 Pascal. We can say that it is 2 Pascal. Now if we are going to take the block in this orientation, what is going on here? So here pressure is equal to force 24 over 3 2s are 6. 3 multiplied by 2 is equal to 6 meters square is the area. 4 Newton per meter square or Pascal. So here you can see by decreasing the area under that block, we have increased the pressure. When we increase the area, the pressure is decreased. So that is why the area is pressure is inversely proportional to the area. Is it clear? It is clear that how the pressure can be changed by changing the area under that body. Yeah. Here we are not going to consider the total surface area. We are only considering the area at which it is lying, only that area under that block. G. I also gave you the example of pressure, that when you are cutting with the help of the knife, then sharper the knife, more will be the pressure. Because if the edge of the knife is sharper, then the pressure will be more. And then we also discussed the example of nail. If the end of the nail is pointed one, too much pointed, then more pressure will be generated.